that, I want to introduce Dr. Glenn Lee. For those small teachers who have been around for a few years, you know Glenn from the Bioenergy Project. He is now part of food science and has been working on this USDA project with us and developed a series of activities, two of which you got a little less than a year ago, and you're going to get 3 more over these next 2 PD sessions, one today that you're at right now, and one next Thursday at 4 p.m. as well. So with that, I will turn it over to Glenn to talk about his activities.
Okay, thank you, Jay, for the intro, and welcome again, everyone. So I'm going to start sharing my screen because I have a couple of slides today. And actually, so I have 2 lessons that I want to go through today, and one is related to bread making, and the other one has to do with JELLO. So these 2 are both food science schemes, and they're easy to do for students at home. So remote delivery is definitely compatible with these lessons, and they're linked to a number of NGSS concepts and learning outcomes, and they're quite pertinent to science classes in general, particularly biology and physics and chemistry. So let's get started. Now, a little bit of recap on why are we interested in using food science as a media to convey scientific concepts, because food science is multidisciplinary in itself and also touches our daily lives on many different aspects. For example, we all hear a lot about food safety issues that concern the general public. There's increasing awareness of nutrition and also the sustainability of our food supply. Particularly, these things are also highlighted during the pandemic. Right? So things are coming into the scope of almost all of us, whether the supply chain of food and nutrition can sustain disruptions caused by COVID. And so these are good ways that we can take advantage of to prime our students to engage their interests. And after all, food is something we all love, and particularly for students to have an enthusiasm in food and also even a potential career interest in food after they've grown up. This is also a good way of introducing them to science concepts. So as for the lessons, we'll go over 2 lessons today. One is called Cool Bread. It's basically a bread baking activity, but it has a sensory component to it. So what we will be comparing is bread that was baked from loaf that are fermented under a cold environment in the fridge, and versus bread that was leavened just under regular room temperature. Anyone actually baked cold bread before? No? Okay, so that may be a new experience for you as well. So that's the first lesson. The other lesson is it's about JELLO, which is something that we made before, and we'll go a little bit of after a little quantitative activity with JELLO this time around to measure how melting points of JELLO can be altered by the addition of either sugar or salt, and discuss why that was the case, and also what potential applications that can come out of this physical phenomenon. So interrupt me with questions anytime because we don't have a lot of attendance today. So I'll start with the first lesson. I actually listed a few examples of schemes in NGSS that are relevant. So bread making is pretty straightforward. In this particular lesson, students will try to, number one, proof the yeast. But depending on the the person you talk to or the baker's vocabulary sometimes is also called blooming the yeast. This is unique to active dry yeast, so you don't need to proof the yeast if you're using instant yeast. What proofing means is mixing yeast with warm water, usually lukewarm water um, around 100 degrees Celsius, or from 90 to 100, actually helps yeast to acclimate to a new environment and balance its solar osmotic pressure and start propagating. So proofing active dry yeast helps the yeast get a head start before it's pitched or mixed with the flour or the dough. So in the lesson, students had the opportunity to compare whether proofing the yeast or not proofing the yeast cause a difference in the extent of how much the dough actually rises. So they'll use a ruler to measure the size of the dough before and after the rising. And so essentially proofed yeast will be more active, generating more carbon dioxide, and then the dough will rise into a larger size. So that's one part of the lesson. The second one is the effects of refrigeration on the leavening of dough. And so cold fermentation makes the yeast in the dough to propagate slower. They metabolize slower. They release the gas slower. Over a longer period of time, they still accumulate CO2 and the dough will still rise. So in comparison, cold fermented dough should be ready overnight, but you can let it ferment in the fridge for 3 to 5 days, depending on the recipe. Whereas if the dough is left, say, on the current hot or room temperature, then or even under a little bit higher temperature, for example, about 90 degrees C or 100, sorry, 90 degrees Fahrenheit or 100 degrees Fahrenheit, then it takes about half an hour to 1 hour, and that should be ready. So what are the difference? Well, when you are doing the lessons in your own kitchen, or with students doing them in their own kitchens, the outcomes could vary quite a bit. So be prepared that you're not like seeing a standardized outcome. And the sensory properties of the bread itself can be affected by a lot of different factors. For example, how it's baked in the oven, the actual type of yeast, the type of flour used. For example, some flours have a higher nitrogen and gluten content than others, and so on and so forth. But generally speaking, refrigeration helps preservation of some low boiling point metabolites that are produced by the yeast during the rising process, mostly alcohols that gives the dough its sweet aroma. So these aroma compounds are usually chemicals with low boiling points, which means at lower temperature they tend to stay in the dough in comparison at a room temperature or around 100 degrees Fahrenheit, the turns evaporate and flash off. So a cold fermented dough have a more richer aroma profile. So this is the point where as teachers we can explain to the students why this is the case and what we're expecting. So it's an example of hypothesis-driven research or testing, right? So before we bake the bread, we think, well, maybe they'll taste a little bit different, and then students can actually have a discovery moment once the breads are baked. Another impact of fermentation temperature on the final bread property is the sensory properties. So yeast not only produce CO2 during the rising process, they also metabolize proteins and carbohydrates within the dough itself. So yeast is capable of producing amylases and proteases that partially degrades the polymers in wheat or in dough, and as a result, that reduce the polymer size and produce fragments of polymers during this enzymatic degradation process. So the activity of these enzymes are also related to temperatures, and at low temperature these processes are also retarded. So as a matter of fact, the polymer matrix in a cold fermented dough is to a great extent preserved compared to a dough that's fermented at a room temperature. And that results in a stronger texture of the eventual bread. So bread tends to be more chewy after cold fermentation and baking. So I think I explained these already. So just for those who are interested on what kind of flavors are affected, this is actually from a research article. Very busy table, but I'll walk you through this. So OAVs are essentially volatile compounds that can generate an odor response. You can smell them from the rice dough, so you can actually see, depending on the amount of yeast added during the rising process. So if you look at this whole profile of, let's see, I'm gonna try to turn my pointer on. Yeah, okay, this helps. So these are examples of alcohols, and a couple of them are actually esters. So ethyl 3-methyl etanoate. This is actually an ester that gives a fruity smell to the bread. And as you can see, with more yeast added during the rising process, these odor compounds are released at higher amounts. So if you are looking at some of these esters, it looks like they're more or less the same. Well, maybe there's some difference depending on the fermentation temperature, and that affects how much of these are released. But if you look at these alcohols, those that ends with NOL or OL, so these are long chain alcohols that also confer odors from bread. You can see that lower temperatures of fermentation actually help preserve a greater amount of those things. This is one example. The malty smell is reduced about in half if we're comparing fridge fermented dough versus room temperature fermented dough, and that difference can be seen with a number of other flavor compounds as well. For example, the second one, balsamic smell, and to an extent, the buttery smell as well. So yeah, these are examples on how fermentation itself can be affected by the environment that the dough sits in. So this is the lesson also provides an opportunity for you to explain. When we're doing experiments, there is a natural outcome of variations, right? Particularly when it comes to foods. Even if we follow the same recipe every time, and we may be baking these breads in perfect replicas, we can still get different aroma and sensory properties. And to maybe asking, why is this the case? Well, this is because there are a lot of complex physical and chemical processes that are occurring during fermentation, and for each of these processes, they actually follow a normal distribution or have its own degree of variations. And all these variations adds up and propagate, right? So basically you can start with the same materials, follow the same strict formula, and end up, you may fall into a range of different possible outcomes. So that's another scientific concept that students can come across. So, okay, next slide. There are a couple of questions that may pop up in your class. I just want to prepare you a little bit for these. How long can the bread stay in the fridge? They can stay a fairly long amount of time, as long as they don't get spoiled. So there are certain spoilage microbes that are resistant to cold temperature. So, well, they're not necessarily cryogenic, but they can't withstand 4 degrees Celsius or 5 degrees Celsius conditions in grill. So that's something to watch out for. 3 to 5 days is definitely safe enough as long as the services that was used and the hands were used to make these doughs or prepare these ingredients are not super dirty. So we're not, as long as we're not introducing spoilage microorganisms in that way, and as long as we're introducing yeast cells in the correct way, we're proofing the yeast strains and also we're pitching them into a dough and they're well mixed, then if that's the case, then yeast usually will be the dominant strain in the dough. So that will have some suppression effects to spoilage. So 3 to 5 days is safe. Some artisan brand makers store their yeast starter, which is basically oats dough, and that's their jargon for it, in the fridge for a very long time. So that's not in practice as well. So it can stay a long time. But for the sake of food safety, you don't necessarily want to extend it beyond 5 days. If students do want to eat the bread after baking, can the dough be frozen? The answer is yes, as long as the yeast was properly proofed. But the ability of frozen yeast to generate CO2 is reduced. So if the dough has already rise, then you can freeze it and store it just fine. If the dough has not rise at all and they're just mixed and kneaded, then freezing it will adversely affect how much the dough can still rise after you thaw it at a later time. What is the difference between active dry yeast and instant yeast? They're different in terms of formulations and their strains. I probably won't go into exhaustive detail today, but you can find a lot of resources online. But the short answer is instant yeast are formulated to the extent that they can be added directly into the flour during the dough mixing process without the need of proofing, whereas active dry yeast needs to be suspended into warm water, and ideally that yeast suspension needs to sit for about 5 to 10 minutes for it to become ready to be pitched or to be added to the flour or the dough itself. So that's a major difference. Okay, I'll take a quick pause here in case anyone have any question about this first lesson, the concepts, and how we do it.
Feel free to unmute yourselves and ask questions. Also, you can type them in the chat, and while I may not be able to answer them, I can give them to Glenn.
So, Glenn, a quick question I have. This is Chris.
Mm-hmm.
So, if I actually teach culinary arts,
nice.
Teach kids how to cook at the high school. So, this is very interesting. So, if I have instant yeast and I proof it, does that destroy the yeast or does it speed up the process, which then would cause the bread not to rise correctly later?
It doesn't really do anything. So you may be able to get away with a smaller enough pitch amount of instant yeast if you choose to proof it, because yeast will propagate a little bit when you're proofing. But the difference is not really noticeable. You don't really kill instant yeast if you do proof it though. It just so if you proof it for too long, then that may be a problem, because as yeast colony grow in the proofing water, it will be deprived of nutrition and start making these sulfur compounds. So yeah, and this is more of a question if you are trying to brew something, because those compounds are more noticeable in, for example, beer. So there are something called reductive smell or sulfurous smell that sometimes winemakers talk about. That's coming from dead yeast. So if you let yeast leave it on the dry run for too long, then you start having things like that. But I assume, Chris, you're not teaching cider making or winemaking in your classes. That's an interesting side note to have. Okay, so if you have more questions, we can keep time in the chats. Moving on to the next lesson, JELLO. So you probably have made JELLO in our home as well, or maybe as part of our lesson, is a polymer gel of gelatin. Gelatin is long chain proteins that are entangled together. It's derived mostly from animal sources. And so, well, there are plant-based gelatin too. I should stand corrected. So JELLO is basically a gelatin gel. The polymer forms a matrix, and inside this matrix there are these void spaces where water or the solvents in general can fill in. And so you may have a small amount of polymers added as solids, but as they form these cages that contain solvents, the overall gel can take a much bigger volume, as you can experience when you're making JELLO yourself. JELLO also demonstrates melt behavior. So after you heat it up to a certain temperature, usually about between 30 to 35 degrees C, it starts to melt. And vice versa. So you can have warm water, a blend of JELLO, and then as it cools, it solidifies and forms a gel. Not exactly like freezing water into ice, the crystallization process, but it solidifies. And the process is reversible. So in this lesson, we're trying to add salt and sugar to the JELLO, which makes the JELLO less edible, particularly for the salted one. But we will be able to observe how these additives change the melting and freezing behavior of the JELLO itself. And we'll try to measure these things quantitatively by gradually heating up cured JELLO and see at what point it starts to turn into a liquid slurry again. A little bit on JELLO itself. So this is artistic, as you can see, a microscopic picture of a JELLO. So you can see polymer chains entangled together, and they form a network within which there are these storage spaces where you can have water molecules. And these water molecules can freeze as well, so into ice chunks. So frozen JELLO will have some of those, and as temperature lowers, the mobility of these water molecules are released because they're sitting in this polymer cages, and as their mobility reduces, they form networks of hydrogen bonding, which is very similar to ice, and this is why we have a solid form for JELLO, because the mobility of water molecules in this gel are so low that they're no longer flowing like water, but they can still wiggle around, as you can see in the case of JELLO. So in this lesson, we're making JELLOs in these Dixie cups, as you probably have been doing in your kitchen. But in some samples, we're adding salt and sugar to it. So you have salted JELLO and sugar JELLO, and you can observe how they solidify differently. If you add enough salt, the JELLO will just not cure, or it won't turn into JELLO. It will remain a slurry. So for those that does cured, well, if you add sugar to it, they'll still cure just fine, maybe a little bit more slowly, or you need to go even lower temperature or for a longer period of time for it to fully cure. It demonstrates different melting behavior when you do heat it up. This is what we call a straw test. So you can stick a straw to the center of this Dixie cup with JELLO in it, and put this cup in the microwave, put it on to defrost, and heat it for increments about 5 to 10 seconds to make sure that we can catch the actual melting point. So heat it up, and as long as the JELLO starts to melt, you can see the straw slumping in the JELLO because it's no longer solid. So when you see the straw fails, then you can take it out and use one of those instant freeze thermometers to measure the temperature of the JELLO, so you can get a measure of the melting point. The beauty of JELLO is the melting point is reasonably close to our body temperature. And I assume you probably have one of these soft tip thermometers at home, so that will do the trick. And students may have such things at their home as well. So I don't recommend using like a ear thermometer or anything IR based for this activity because, well, microwave may not heat up the surface evenly. So using a soft tip thermometer works the best. So the ones with sugar and the one with salts will have decreased melting temperature and also decreased freezing temperature. In the case of salt, it decreased the melting temperature so much that it may not solidify in the fridge after all. So this phenomenon is called freezing point depression. It has a lot of applications in the food industry and also in our daily lives. One example is antifreeze that we use in cars. So that's actually a chemical that can reduce the freezing temperature of water. So with that sprayed on our windshields, then that make it harder for water to freeze. This also apply on the road as well, as you probably know. But again, salt can be corrosive, so there are more environmentally friendly versions of, and also safer version of antifreeze products out there already. Usually those are glycol based. But yeah, it's similar phenomenon. So in the case of salts, which is sodium chlorides, sodium ions and chloride ions, they form ionic associations with water molecules, and that disrupts the natural capacity of water molecules to form hydrogen bonding among themselves. So this really disrupts the hydrogen bond network and make it harder for water to freeze or to turn into jello. So yeah, just want to move forward to a couple of possible student questions. One is, well, what are the potential limitations of this phenomenon? Well, sugar and also salts are commonly seen in a wide variety of foods when it comes to ice cream. And in the context of food processing, this has to be taken into account. So these food products or frozen food products, they won't freeze at room temperature anymore. They actually have a lower freezing temperature. So this affects the storage, affects the production, and also the distribution of such things as well. So some students and some teachers also may have did homemade ice cream before. That also involves using low temperature ice water that are salted. So this takes advantage of the same phenomenon. So ice water, once salted, have a much lower freezing point. And the freezing and thawing process itself entails heat transfer, and that's being taken advantage of to make ice cream. So what are the potential applications of this phenomenon, or how can we take advantage of freezing point suppression? Well, there are many, particularly in the food industry, where we want freezing to occur so that water can crystallize and the other components of the food does not crystallize. This is very useful in beverage processing. One example is the concentration of coconut milk. So coconut milk has a rich flavor profile, and those aromas and flavors come from low boiling point compounds like alcohols and esters that can easily flash off or evaporate if we are just boiling coconut milk for the sake of concentrating it. So if we do want to remove the water content in coconut milk, one viable technology is called freeze concentration. So as we freeze this, water forms these crystals first, and coconut milk itself, because of freezing point depression, they can remain in a liquid form even if some of the water has already crystallized. So we can get rid of the water crystals and then retain a not yet frozen coconut milk as a concentrated product. So freezing is also used to remove water in a process similar to distillation, and yeah, so it can be used to distill alcohol as well. So freeze distillation has been used by home distillers to make distilled wine. A lot of recipes for that. So this is not naturally something appropriate for middle or high schools, but it may not be a bad thing to refer to. And while distilling is not necessarily legal in some countries, but in the United States, the regulations are less lax. It's not commercial. So these are the good things to mention too. But freezing wine actually helps some of the water to crystallize and get separated from the wine itself. And that's how you can increase the alcohol content of the distilled products. So yeah, distillation doesn't necessarily involve the use of heat. It can be done via freezing as well. I'll stop a little bit more. And this is actually the end of my slides today. So any questions about this JELLO lesson in particular? It should be pretty easy and intuitive. When we're making these gels in cups, I recommend using paper cups or Dixie cups. So that way they can microwave just fine. So literally any microwave container should be okay. As long as you don't use metal container, then it should work just fine. Another reminder I want to bring up is using defrost on microwave is kind of important. So if you're using a high power mode to thaw the JELLO, it may be a little bit dangerous because the high power will result in uneven heating within the JELLO itself, and some part of the JELLO may reach too high of a temperature that steam may be forming already, and that can cause some explosive action, even if the other part of the JELLO are still in a solid form. So there may be some splashing happening if someone inadvertently heat up JELLO with high heat instead of defrost.
Glenn, a quick question. It's Chris again.
Yeah.
Does it matter if you use white sugar or brown sugar or when doing the JELLO experiment, or is that something we could experiment with the kids on the melting point?
So brown sugar and cane sugar doesn't really make a big difference because they're mostly just sucrose. Salt and sugar make a pretty big difference because salt is ionic. So it's if you want to try other things like MSG, that can also have a depression effect as well. So what else we could try? Artificial sweeteners. That's an interesting one. It can also cause depression, but to a lesser extent. So yeah. Another thing to experiment with is you can also go quantitative with this activity because the extent of freezing point depression is positively correlated to the amount of these additives. So basically, the more salt you add, the more drastic of an effect you can see if you're able to measure the melting temperature. So basically, you can choose the different levels of salt addition. So if you add, for example, 5 grams of salt per cup of JELLO mix, then that should give you a decent amount of freezing point depression. So if you want to decrease from that 5 gram per cup, then you can probably see like a gradual shifts of freezing temperature as you're measuring. That's an option too.
Glenn, I have a question for you.
Mm-hmm.
So, when I look on the back of things like ice cream and other products that may be JELLO-ish like,
yeah.
I see a lot of other things. Guar gum, xanthan gum,
yep.
carrageen, agar. Like these are other things. And do they put those in because they have different melting points? Are they changing the melting point by adding those, or are they doing something else?
Yeah, great question. So I need to formulate a very long answer because these additives all do very different things. So guar gum and xanthan gums are very similar in nature. They are very absorbent solvents, so they can form a gel by itself. And as you may be able to look online and find middle school lessons that makes xanthan gum based gooey or slime. So xanthan gum can actually absorb water and form a slime. So in the case of ice cream, it helps to reduce the amount of free-sitting water or water pockets within the mix. So you have much smaller or even non-existent ice crystals, which is important in ice cream making because you don't want large chunks of of ice in ice cream because that's a bad thing for the smooth mouthfeel of the product. So yeah, the case for carrageenan and agar, so these also form gels, but it's more of mouthfeel modifier and also increase the degree to which you have distribution of small air bubbles within the ice cream. So the air bubbles itself is introduced in the ice cream making process so that we achieve the actual density of ice cream itself. This is just a quick trivia fact. Ice cream itself, by volume, is about 50% air. Yeah, so if you have none of that air, then it would just result into a big chunk of ice. So agar reduces the mobility of these air bubbles during the ice cream making process so that they stay in the ice cream without escaping, which is also important because you do need air for mouthfeel. And these are also food-derived polymers, so they're safe to consume as well, and they're low in calories as well. So yeah, that's kind of why we have all these things. Great question, by the way.
I had another question, and it was on the other activity. You were showing this the chart that had all the different alcohols on it that were produced by the yeast. Some that seemed like beneficial smells, like that we associate with bread, and others that maybe we'd want to avoid. When they're mass producing bread that you may get at the store, are they adding these artificially to bread to sort of heighten these smells? Are they trying to remove some of them that are potentially that they don't want? How do they go about doing that?
But yeah, good question. So, well, short answer is no, they're not purposely adding any of these. Mostly out of cost considerations. So basically, bread is a low-cost commodity, and these chemicals, although they're not necessarily costly, but it doesn't really make a lot of sense to add them after effects because usually it's not necessary. These chemicals are also present in the baked bread in such small amounts that if you want to dose it to the correct level, it's kind of challenging. For example, the floury alcohols have very low sensory thresholds, and you don't want that one or several particular compounds to dominate the rest. With that said, it's not necessary. It doesn't mean that people cannot do it. One example is the use of essential oils. Essential oils are essentially a mixture of a number of alcohol extracted from various sources. So, yeah, if you want, you can add essential oil into your dough and bake essential oil flavored bread. I don't know how, well, I never did it myself, but it's definitely possible. Another example of such addition is lime bread or lime cake, because lime naturally contain uh, some of these citrus alcohols and esters, and of course they will be retained in the final product. What is most common nowadays in commercial bread making is the use of genetically modified yeast. So yeast are also bred yeast strains. So yeast strains are bred, like selected, and also genetically modified so that they produce a desired profile of aroma compounds. And yeah, so there are a lot of commercial yeast collections that produce desired profile of aromas. This is also how certain bakeries can feature, their bread of a unique aroma or flavor because, again, they have this yeast strain that deliver consistent results. This is not only the case for bread making, so in brewing and wine making, specialty strains of yeast is also a thing because they're capable of generating these unique aroma profiles. So, yeah.
Excellent. Thanks for answering those questions. Any other questions out there? Feel free to unmute yourself, ask them now, throw them in the chat. Just to remind everybody, in that chat, you are going to find links to get to these lessons. These lessons will be posted on our website. And for those of you asking questions, we will be sending out another box with materials that have a lot of these materials in them. So if you're wondering those, we got you covered. It'll be there ideally by the end of the term.
So, Glenn, a quick question again. In my cooking class, we make it's like a 2-day cinnamon roll. And a couple of years ago, we had Snowmageddon over here in Eastern Oregon. I think they had it in Western Oregon too. I don't know.
Yeah.
But the kids spent 8 days making cinnamon rolls instead of the typical 2. And so with that, we found out that all of our bread smelled like really strong alcohol.
Yeah.
And is that just now? I'm not a chef by trade by any means. I'm actually a geology major and a major disappointment in a lot of other things in life. But the kids, we cooked it, and the kids basically, because it's an instant yeast, and most instant yeast, that's all one strand. Is that correct?
Yeah.
Okay. And so some of the kids ate it. They thought it was great. Other kids were like, nah, I'm not even touching that. And so the longer the yeast goes in the fridge or not, it's going to produce the alcohols and esters, correct?
Yes. And it really depends on the availability of oxygen and nutrition. They produce drastically different profiles, these things. So if there's more oxygen presence, then you see less alcohol, presumably.
And that's what your chart is showing. Is that correct?
Well, the chart is showing the effects of temperature and also the amount of yeast you're adding. So the higher temperature reduces the amount of alcohol that's left over because alcohol will naturally evaporate because of the heat.
Right.
But if you're doing this over a long period of time in a fridge, then all of that alcohol stays behind. So you may have a raised dough that smells just like beer if you're using this cold-fermentation method.
Okay. That sounds good. I appreciate that.
Yep.
Any other questions out there? So I want to thank Glenn for going over these lessons. Glenn will be back next week with another lesson on how you can use the bread that you make. You can eat it, but you can also do other things with it. And that lesson is going to talk about doing that. And so next week at 4 p.m. But at this time, I want to introduce the director of Oregon Ag in the Classroom. Many of you who have been to our workshops in the past have met her before, but Jessica Jansen, who is a partner on this grant, is going to be setting up and has set up some virtual field trips that we hope you're going to be able to take part in. So I want to let her talk to you more about those.
Wonderful. Thanks, Jay. Hey, would you mind allowing me to share screen so that I can just put a quick image up there? Super. Thank you. So I just wanted to take a few moments here and just introduce a piece of this grant, which is virtual field trips. So we've done a few of these. I'm not sure if any of you have been able to join them so far, but they're just a way for us to continue to engage students in a different way. So we're going to be doing some dairy farm field trips next week on the 19th. And there's a 3rd through 5th grade one in the morning at 10:30, and then a high school one as well at 9 a.m. On November 19th. And then we're also doing a creamery tour for middle school and high school students. So this is on December 7th at 10 a.m. And this is a farmstead creamery that's outside of Canby, just outside of the Portland metro area. They do everything right there on their farm. And it's just a really neat operation and ability for us to really see from cow to cheese. They're going to have their cheese maker there for us to ask questions and really dive into some of the chemistry of cheese making. So I put everything, I actually didn't do this, but in the chat. And the other thing is we're going to be continuing to do these virtual field trips about one a month, be different grade levels. So some may or may not be applicable, but we will be doing some related to the kinds of lessons that we just dove into a little bit here. So some type of wheat and bread making tour, and a couple more food science ones throughout. Most of those will be happening next January and on. So that is the update there. Again, I dropped the links in the chat for the sign up for that. And there's also a sign up just to be alerted of future ones as they become available. So I encourage you to sign up if that's something that might work for your classroom. Any questions about the virtual field trips? Wonderful. We hope to see some of you there if it works for your schedules. Thank you.
Thanks, Jessica. Some of you teachers I put in the chat have been to the Rick Rail Dairy. It's a great tour, so definitely have your students check that out. I did put the slides. Some of you requested the slides. If you follow that link, I'll put it in the chat again since we have been chatting away down here. I'll put it in the chat again, but at this link, you can get the information. You can get the slides that Glenn had. You can get both lessons, and you can get the information about the virtual field trip. So take advantage of that. I'm going to show you one last thing here that you may not have seen before or know how to get to, because we tried to make it extra tricky to do. And that's how to access a lot of the great information and lessons, not just professional developments that we're putting out. So I'm going to share my screen here and show you how I get to it. Let's see here. All right, so hopefully everybody can see this. I always go to Google and just if you go to pre-college programs, look at that right there. You can see here we have our distance education. We're going to be rebranding that because we didn't want you to get too used to it, to virtual education. It's a big difference. But if you go to this site here, from the Precollege Programs website, not from the SMILE website, you can see all the information that we have coming up. And a lot of these are, you see STEM at home activities, and those are great things for you to plug students into, especially, and it doesn't just need to be SMILE students, it can be any students. These are activities to keep students engaged, doing some fun activities. Most of them are webinars, so it allows to follow youth safety regulations. So there's no issues there with younger students. But you can go down here and you can see for the fall 2020 sessions, all the sessions that we have coming up. A lot of those are iInvent. You'll notice that every Thursday there's an iInvent one. You have all the materials to do the iInvent materials in your box that was sent to your school. So there was so those were sent out, and you can, those activities or those materials are packaged in a way that you can just send them directly to students, or students can pick them up however your district is distributing materials. But and if you were able to do them in class, those are materials that students don't have to share. So we're trying to package things differently than we have. Instead of by club, we're doing it by student now to hopefully make it a little bit easier. So you can get all the information. Those are on our calendar. Now, let's say you missed one. You're like, oh my gosh, I missed this one. I really want to do it. It was October 20th and I wanted to make my own homemade lava lamp. Well, just click on it. They're all recorded here. And so you can, have your students watch it. You can have your class watch it. Now, not all the materials for each one of these is there, but we provide material lists, and we're really trying to concentrate on those materials that are easily to source, or hopefully students would be able to source at home. So take a look at those. I think there's a lot of good resources here, and they're going to keep coming throughout most likely the end of this school year. Same thing here with the virtual professional development. We are having those sessions here. You can see you just are at the cold fermentation for bread baking. What makes food spoil? We're going to be doing that next week with Glenn. After Thanksgiving, we're going to have some more of our multilingual learning strategies with Corey Buxton from the College of Education. We're going to be talking about the time looper that you may have heard about at the August teacher workshop. We have a lot of really great PDs coming up. So keep checking there. And I've been sending out emails once a week just with reminders of PDs, materials in the boxes, and other lessons that are coming. So if you do have any questions, you can always just respond to those emails and I will answer you. So is there any final questions? I see one from Ms. Jones in the chat here. Jessica, are you recording the field trips?
Yes, all of the field trips are recorded, and actually if you go to the website, there's a spot where you put all of them in an easy to find location. So yes.
Oh, look, I didn't go down far enough. What? Yes, here they are. So virtual college connections, are they here?
Oh, on our website, I'm not sure. Are they also here? No, I don't think they are.
So they're on Oregon Ag in the Classroom.
Yeah, yep.
Okay, so you go to Oregon Ag in the Classroom and
go to programs and then virtual field trips.
I went too fast.
Oh shoot, we need to add it there. Ah, you just found an error for us. Thanks, RJ.
Virtual field trips, you go right here.
And then just on the right there, you'll see it, watch previous virtual farm field trips on the very bottom of that list in the section.
Yeah.
And there they are.
So there's quite a bit of materials here. So a lot of, I realize, screen time and kids are getting zoomed out, but there is a lot of asynchronous resources that you can provide to your students, SMILE or non-SMILE students, just to keep them interested in learning as they are being stuck at home. So I want to thank our presenters, Glenn Lee, Jessica Jensen, and thank you all for taking the time to come. We will be having another session, as I said, next Thursday, 4 p.m. And you can find the link either in your email or on our website. I'll stick around to answer any final questions, but at this point, thanks again for coming, and we'll hopefully see you soon.